welcome to Ditch Diggers Dialogue Volume 14. My name is Ashley Hudson, and I am the Operations Manager with the Heavy Construction Contractors Association. If this is your first time tuning into a Ditch Diggers Dialogue, welcome. HCCA strives to provide educational and networking opportunities for our membership, so we created the Ditch Diggers Dialogue series as a virtual way to stay connected. With 33 years of experience in the lubricants industry, Walt Silveira of Chevron Technical Services joins us today on behalf of HN Funkhouser to discuss efficient fuel usage and engine aftertreatment systems benefits as they relate to oil. HN Funkhouser seeks to educate their customers on the fuel economy, and the representatives on the call will be happy to discuss options with you after the event. During today's session, we ask that you keep your microphones muted until we open the floor for questions. If you have questions or thoughts as we move through the presentation, I encourage you to type them into the chat box as we go so they can be addressed at the end of the presentation. Now I will turn it over to Walt. Thank you for being here with us today, Walt, and the floor is yours.
Thank you, Ashley, and welcome everybody. And I appreciate the opportunity to hopefully educate and help all of you understand a little bit more about lubrication and how it affects today's Tier 4 engine aftertreatment systems. Chevron has been working on some technology and working to support this industry over the years as we have seen the emission control systems with Tier 4 and Tier 4 final having a great impact on everyone's operations. So today, hopefully, my goal is to give you some useful information, a little bit about the technology. Oil sometimes is not, I guess, on the forefront of most people's minds when thinking about engine aftertreatment systems, but it does have a significant impact on your operations, your costs, and your availability of your equipment, for your operations. So one of the key things I'll mention is over the years, there have been great strides. I mean, emissions technology from the OEMs has come a long way. We think about just this picture here shows the amount of soot or particulate, as it's particulate matter as we refer to it, in past years. And in the 80s, you might 120,000 miles on I know we're looking at a on-highway vehicle, but the same thing relates to off-highway too, where you see with those amount of miles, the close to 500 pounds of particulate getting into the atmosphere, versus today, with the new emissions equipment and technology, with 120,000 miles, you're seeing less than 8 pounds of particulate. So some great strides there, and I'll talk a little bit of how the oil technology has followed along with the engine technology. In some cases mandated to make a move, but in other cases where our folks also have been working on specific technologies to help all of you, our customers. So one of the key things that I'm not sure how many people completely understand, but the DPF system in your aftertreatment systems, one of the key things is the oil has a significant impact on the life of that DPF. And in fact, the actual when you have to actually service those and change them out, whether that's 4,000 or 5,000 hours as recommended maybe by the OEM of your equipment, most of that is due to what comes from the oil that is actually plugging up the DPF. And we'll talk a lot about that. So the oil has a significant impact on the service intervals of that DPF. The other area too is that the products that come from the oil that are plugging up the DPF also have a great impact on your fuel economy or your fuel consumption. The regenerations, we'll talk a little bit more about that, the regens or the forced regens that are happening, and the back pressure that is caused by that filter, that DPF actually being plugged, can actually consume in excess of 3 to 5% more fuel than you would normally have done without the DPF system. But there are answers. Like I said, technology is with us, and we've been able to work on different types of innovations to help us improve on that service life and improve on the total fuel consumption that you're generating. I'm going to start, I start here in a lot of courses because many folks have, although you go by the OEM specifications for the oil that you should be using in your, whether it's your own car or actually, in the equipment that you have today. The journey started many years ago in the early 1900s. Automobile engines, this classification system, as we call it, the API classification system, started many years ago to help develop quality oils to meet the requirements of the OEMs. So when we look at what CAD and Komatsu and look at your own vehicles, as technology changes, as emission systems have changed, so have the need to upgrade or modify the formulations of the oils that are servicing these, the engines. So you can see these bars here on the, there's been along between the 40s and all the way up to almost the 70s. There's very little change in the oil that the formulations that we had. As we started getting into technology changes, so in most cases, technology that has driven the engines has driven the oil technology to change also, and emissions. So as we move from, say, the 2-cycle engines, as we got to 4-cycle, and then we started, if you look down here, every one of these bars is another classification change. So you can see how rapid the changes started to occur as we moved into the recent couple centuries. So one of the key things as we have moved, we've had to continually upgrade our oil. A good example of that would be in just oxidation control. So with the newer engines, as we've seen higher temperatures, higher combustion chamber temperatures, we needed to upgrade the lubricants so they would not oxidize and they would not cause acidic types of formation that can cause premature wear or premature engine life. So as technology has changed in the engines, so have the oil manufacturers, so not just Chevron, but the other oil companies too, to work on newer technologies so that you can actually have the life of the equipment that the OEMs are trying to work towards. I will say a kind of neat, quick example of that would be even today as we see engines moving towards higher temperatures, better fuel efficiency, with common rail, high pressure systems, variable geometry turbochargers, and the equipment on the after treatment systems, the temperatures that the oils are exposed to are significantly higher than they ever were. So the oils that we are producing, both from base stocks to additive technology, significantly are significantly better in oxidative control. So some of the key things that you'll see as these categories change, the formulations are improving every time. So this is just a quick chart, and I just want to show that we've continually been improving to a point, sometimes dictated by the OEMs, what we can actually do, or the API says that we have to make an oil that does this and meet these tests. A couple key things that have happened over the years, especially in the diesel sector. You'll know that, we'd always see either 50 weight back when the 2 cycles, 2 strokes. Now we're looking at 10 W30s, which was more common overseas. But as we have moved towards providing more fuel efficiency, not only in the on-highway market, but in the off-highway market, 10 W30s are becoming a common recommendation, such as from CAT. So one of the key things is this API donut. And the one key piece I wanted to point out is this CK4. So for those of you that may be familiar with this, as you see these categories move down into the latest category, the latest API certification, it's a CK4 specification for today. And it's just the next letter follows it. So C is for compression. And then we just moved down all the way from A all the way today we're at CK. And I actually have this same chart for a lot of people say, well, what about my personal vehicle? At the end of the presentation, didn't want to spend a lot of time on it, but I do have this chart that you can view. It's for your automotive products too, how the S, so if you look in your owner's manual, it'll say SA all the way to SP, and the S is for spark ignited. So C for compression, S for spark, and that's where you get this API next service category as you look at your owner's manual, whether that be in your car or for CAT, Komatsu, off-highway piece of equipment is where you get the API credentials. So let's talk a little bit about what's in a barrel of oil, because it becomes very important to the impact it has on the DPF system and your emission system. So a typical barrel of oil is what we would consider base oil. So it's about 75%, and this is typical for your automotive oils also. You'll have about 75% is just the base oil, which makes up most of the viscosity, like that 5W30 or 1030 or 1540. The other components that are really important in an engine oil are what we call viscosity index improver, and that's what helps us manufacture a multi-grade lubricant. So when we want to change a straight 30 weight or a straight 40 weight to a 15W40 or a 10W30, we need to give the oil the very low temperature properties so it will flow or pump in that cold temperature or startup conditions. So this viscosity index improver makes up somewhere from 8 to 10% sometimes, depending on the formulation. The key additive area we're gonna focus on today is what we call this detergent dispersant type of package, which makes up anywhere from 14 to 18%. And these are those additives that we talk about to help with acidic control, deposit control, helping us with wear, the protection of wear in the valve train or inside the cylinder of the engine. And in those components we sometimes call ashless. So ashless meaning that they're non-metallic, but it's these other components, the zincs and these other detergents like calcium and magnesium that are metallic, and if burned actually create what we would call ash in our industry. So if you took the components that have been very important in development of car and diesel engine oils, these are metallic additives, and they can turn to a metallic property when they're exposed to severe high temperatures. And many of you who've been around long enough will know that these detergent, calciums, magnesium, zincs, make up what we have always talked about to be a good TBN, or a total base number. So all the fuels that we've used over the years had sulfur, depending on the level, they've come down quite a bit. And that sulfur during combustion would create these acidic byproducts. And it would be these additives that we would need to actually neutralize those acidic products to help protect the inside of the engine. But over the years, as we know, sulfur and fuel has come down significantly. And so we've been able to modify these detergent dispersant types additive packages to be more appropriate for what is happening inside of your engine. So we'll talk more about this ash product in a couple of slides, but remember that the ash actually comes from the oil. It's from these detergent dispersant additives that are inside the oil. One of the other key things is there we go. Those key two primary functions of these detergent dispersant additives are protection at these high temperatures for the pistons and turbochargers, and then this protection of corrosive wear, as I mentioned. Just a little history on the emissions, where we've come on emissions. And one of the key things is, as I mentioned in the last slide, is the amount of fuel that sulfur in the fuel. So if we look back into the 1990s, almost back into the 80s, where sulfur in fuel was over 5,000 parts per million, you'll see we've significantly reduced the amount of sulfur in the fuel. So not only have the oil and engine technology changed, but the refiners that have actually made fuel have been mandated through emissions regulations to start reducing the amount of sulfur in fuel. And today we are less than 15 parts per million, sulfur in fuel, or ultra low sulfur diesel, and many of you are familiar with that. But part of this, I mentioned this here because the sulfur played, as I mentioned, plays a big role in the acidic formation of byproducts inside of the engine. And as we've been able to reduce the sulfur packages that didn't require as much of that detergent dispersant packages, as we reduce that fuel percentage, or the sulfur in the fuel is reduced. So these boxes here, I'll call the emission box. So you'll see the emission box was very big back here in the 80s, and we move all the way down to today's regulations for emissions. And one of the key components is this particulate. So with the sulfur reduction, as over the years, the EPA has basically said we need to reduce that particulate. And the particulate is that soot that is being produced, that black smoke that was going out the stack. So one of the key things that with engine technology has been to reduce that particulate. The other piece of this was not just the hard particles going into the atmosphere, which could cause pulmonary or breathing types of issues, would be the nitrous oxide or the greenhouse gas effect. So the other part of reducing this box was not just the particulate, but now the NOx emissions coming out of our engines. And you'll see today that emission box is virtually disappeared today. So technology has really done some amazing things with first with the EGR system, and then with the DPF, and recently with the SCR systems that are in diesel engines. And I bring that up because as we talk about these, I guess, breakthroughs in technology for the engine, one of the key things when they introduced the DPF system in 2007, one of the key things that was mandated by the American Petroleum Institute that designates the CK4 type of lubricants was that additive level, that those detergents, dispersants that I showed you in that previous slide, that they would need to be a maximum of 1%, where we were in the early 90s in the over 1.5% of this metallic additive. And so reducing the amount of that detergent dispersant that we use to help protect the engine, reduce the acidic byproduct formation, we were now being told that you have to reduce those metallic additives down to 1%. So it was a major reformulation change because those were the additives that, one, protected the engine not only from acidic byproducts, but wear components. So they were key additives to help with wear protection inside the engine. So we were actually, so oils today are mandated that they would have less than 1%, because that if you have, they're trying to help with those metallic additives from being accumulating inside of this diesel particulate filter. So it's the additives that are inside of that filter when they go down the exhaust stream and get in the DPF and get incinerated, they turn into that metallic ash. And I'll show you a slide of that coming up. So the key thing is particulate matter was key to the emission control, and then the greenhouse gases, which was really taken care of by the EGR and now the SCR system. If you take a look at the emission systems today, you start with the EGR system, and that was the original to help with nitrous oxides in the emission systems. The second edition, as we mentioned, was in 2007, was the DPF. And one of the key things with the DPF is not only were additives from our perspective restricted a little bit, because the DPF also contains catalytic material, metals, that can be poisoned with certain types of additives. So part of the diesel particulate filter does have a catalyst that helps increase the temperatures inside of the DPF to burn off the soot that gets trapped in there. So the main function of the DPF is actually to trap those particulate matter that from unburned fuel, that soot, that is actually going out the exhaust pipe. And it does that, it's about 98% efficient in doing that. And what happens is, as the soot accumulates inside of that diesel particulate filter, there are three events that happen during regeneration. One is what they call just active regeneration. So as whether it's an on-highway or an off-highway vehicle, if the engine is operating at optimum temperatures, the soot that's being accumulated in here, the temperatures are high enough to actually burn the soot off that's been captured inside the DPF. There's what they call a regeneration phase, where if the soot level gets high enough and it hasn't been burned off in this active phase, then we get this regeneration phase that actually is injecting fuel into the system while the truck is operating. And typically, I've heard it called the seventh injector. There's other names for it. But the only way to elevate the temperatures inside of this DPF is to actually inject fuel, and it hits the catalyst material and basically causes this oven effect or incinerates the carbon, and then it is burned, and then those gases then are able to flow down to the SCR system. And then there's the dreaded where the unit actually has gotten to a point where it actually needs to go through a manual regen phase, and the vehicle or the truck has to pull off or stop working, and it's gotten to a point where it needs to go through the regen process by sitting on the side and not operating. But the two earlier phases are the ones that are normally what's happening, and it's not till you reach the end life mostly of the DPF where you start to see that manual regen process start to be required. So what happens when that ash is burned? This is what those additives look like. So once the additives are inside of that DPF and they're going through this regeneration phase, as you get this oil mist or oil consumption hits inside the DPF, those additives that have been on, going with the oil mist through the oil consumption into the DPF, when they're burned, they turn into this ash material. And so it's the actual ash that is what is causing the DPF pressure, differential pressure to increase, and it accumulates inside of that DPF. And the only way to get that out is, as you guys know, it's to do a service or PM, pull the DPF out, and either whether you do that in shop or send it out to be done, or replace it with a new DPF to have the ash cleaned out. So that's what ash looks like. And as I mentioned, one of the areas that we were restricted with, so this isn't just Chevron's oil, it's all of the oil manufacturers that actually develop and manufacture a CK4 approved oil for your units, that we are restricted by that relating products with 1% or more ash of those metallic additives, which really gave us that performance. So one of the key things of this category when we were reduced to additives, the new formulations, and a lot of new tests were actually built in order to test the new formulations to protect the OEMs in knowing that the new oil formulations would work okay in their engines. And in fact, today, where we've moved to newer formulations, especially on the on-highway market, the same impact for them, that they've seen such an improvement in the formulations that most have gone extended drains by 20–25%. So say a Cummins engine or a Detroit engine, most of them have extended what their typical drain intervals were out by 10–25%, depending on the type of service. So here's the key. With the new formulation and technology, as Chevron's tried to keep up with this event where the metallic additives and the ash actually clog the DPF, we've developed a product with not 1% maximum ash, but actually 0.4%. So one of the key things that is this helps with is if you can impact the amount of additives that are being accumulated inside of that diesel particulate filter, DPF, and you slow down the rate of that DPF being plugged, you considerably slow down the number of regenerations that are being that are happening inside of that engine. So the 0.4% ash, we've heard of ultra low ash products, is kind of the key to this process, where we've gone from that 1% ash to 0.4% ash, which has significantly reduced the amount of diesel particulate filter plugging or the back pressure being developed inside of that DPF. And in actuality, one of the key things when this all started, this is hard to see, but the actual project was to develop a completely ashless product. So not 0.4% ash, but 0% ash. And in that process, if you think about it, if you could have an ashless product and you would have zero amount of metallic additives inside of the DPF would always collect the soot and would actually regen the soot, so it would burn and it would go down to the SCR system and have clean gases going out the exhaust pipe, and you would have zero accumulation of ash inside of the DPF. You would never have to service that DPF. But that didn't work. We still needed a certain amount for the valve train wear and other components inside of that engine. So part of this was we ended up with this 0.4% ash that has dramatically changed the service interval, but not to the point where it's you could go never having to service that DPF. One of the key things that I'd like to show everyone is, what does it look like inside of the diesel particulate filter? So here's your DPF. It's a ceramic type of material inside of it with at the front end where the catalyst, where the exhaust gases flow into is a catalyst material that helps elevate the temperatures to cause that regeneration phase if there's any accumulation of soot. And it's a filter, so everything is basically the mechanics behind it are differential pressures, and it's all tied back to the ECM computer of the truck. But you'll see this is a typical CK4 oil today, conventional oil like our Chevron SDE or any other product out in the market that has 1% ash. And this would be the amount of soot accumulated down here in the gray, I guess you would call it the gray area. So this is the actual ash that has accumulated inside of that diesel particulate filter. So what's happening is the regeneration inside, or when it's needed to basically burn the soot off, is all dependent on how much space is available here for that soot to accumulate. And typically this is actually when a DPF is about 50% full of ash is when it needs to be changed out or serviced. In this area over here, this is with the Dello 680F. That's the name of our current product that has the 0.4% ash in it. So this product here, this would be the same amount of runtime as the conventional oil, in fact, it was run against our SDE, and the same amount of time in service, but significantly less ash accumulation because you have significantly less of those metallic additives. So the service life is, significantly increased. And for the most of our customers, all the testing we've done globally, and this is actually a lab test where we're able to cut the DPF to show these pictures, is where we've seen anywhere from 2 to 3 times on a typical service for the DPF. So, if you're talking 4,000 or 5,000 hours on a typical off-highway type of DPF service, to extend that by 2 to 2.5 times that service life. One of the other benefits of this newer ash technology has been that not only because you have less amount of accumulation, but we realized that this amount was not just, didn't make sense to us because it was even less ash accumulation than we expected. And what we found out is, I like this picture, I'm not sure if anybody else does, but you've got the large cubes and the crushed ice where because of the type of metallic additives we're using, they compact a lot tighter than the additives that we were typically using. So one of the key things that we found with this new technology was not only did we see excellent life in the DPF, but we saw the amount of ash was significantly less because it compacts, or you can get actually longer life from that also. So that was the service life of the unit. The other key impact that we've seen when you can extend the life and have less ash accumulation inside of the DPF, as we see here, was a couple things. One was when you have obviously less back pressure being accumulated in this in a DPF that has more room in it, there's lower back pressure on the engine. And we were able to see that this lower back pressure you have less fuel consumption. So with more back pressure from the DPF and the exhaust system, you see that the amount of fuel consumption can actually increase from just the load on the engine. And then the other part of this would be when you have less of the active and forced regenerations happening inside of the DBF. So when the DPF doesn't have to inject fuel to cause the regenerations to happen during that active or forced regeneration phase, then you're having less fuel consumption from that particular event happening also. So over that, say now you're at 10, 12,000 hours on a DPF. You are not requiring the amount of fuel to actually clean out the DPF because you have less back pressure being accumulated inside of it. So two items, one, the less active area where we've seen reduced ash is in the fuel consumption area. So less fuel consumption due to less regenerations happening inside the DPF. And there's performance, less wear in the engines that we were testing, and stability with this product. So one other unexpected type of attribute of the product that we saw. In your industry, as I mentioned, in the East Coast, the West Coast is a little different because they've been mandated to go 100% Tier 4. With what we've seen with customers here on the East Coast is, a mix of anywhere